Hello. Yes. We welcome you to our channel, Natural Sciences Grade 8 and 9. That's the name of the channel. And today we are looking at this case. It says that identify the closest star from the Earth and state its approximate distance from the Earth. Yes, we see the sky and we see all the stars. But which star is the closest to us from the Earth? The star is Sun. Sun is our closest star, and it is approximately 1,000,000 kilometers from the Earth. That's the distance of the Sun from us here. Yeah, then we come to this question. It says that, what is constellation? Yeah, what is it? Yeah, a constellation is a group of stars which, when viewed from the Earth, they form a pattern or they form a shape. Yes, that's what we call constellation. And there are so many constellations, especially from observation with a telescope. So those are a bunch of stars which, when you see them, you see a particular pattern or a particular shape, is what we refer to as constellation. Yeah, then we come to this question. It says that, give two examples of constellations. Any two. The examples are many. One is Orion, which you call the Hunter. The second one is Crux, which you call the Southern Cross. There is Centurion. There's Proxima. There are so many patterns we see in the sky. Yeah, these are some of the few examples of constellations. Yeah. Then we come to this question. It says that, what is meant by each of the following? The first one is light minutes. Okay. Yeah, what is meant by light minutes? Light minutes is the distance traveled by light in 1 minute. Yeah, that is it. Then light hours. What is it? This is the distance traveled by light in 1 hour. Yeah, that is that. Then light years. What is it? Is the distance traveled by light in yeah, the distance traveled by light in 1 year. Yeah, then we come to this question. It says that, explain the reason behind the use of light units instead of our usual metric units. Yes. What's the reason which tempts us to use light units? Yeah, the answer is that the solar system is very wide, which makes the use of our usual units impractical. These are very wide distances in trillions of kilometers. So it makes the use of the usual metric system impractical. So that's why we opt for use of light units. Yeah, that is it. The solar system is very big, making the use of common metric units impractical. Yeah, then we come to this case. It says that the distance of the Earth from the Sun is 8.3 light minutes. And then the question says that convert the distance in kilometers. Okay. How do we go about this? Okay, you have to know that what actually this means is that light will take 8.3 minutes to travel the distance from the Sun to the Earth. Okay. So in other words, this is what we have. So this is what you have to know, that distance is equal to speed times time. But you have to know that the speed of light is 3 times 10 power 8 meters. Okay? And we know the time. The time is 8.3 minutes, which if you convert it to seconds, it's going to be 8.3 times 60. Yeah, giving you 498 seconds. So what we do, we substitute and we say now distance is going to be speed, which is going to be 3 times 10 power 8, and the time, which is 498. But this distance is going to be in meters. Yeah, so this is what you get, the distance in meters. But the question wants us to calculate the distance in kilometers. So how do we convert meters to kilometers? We divide it by 1,000. So we are going to have our distance in kilometer as 1.494 times 10 power 11 divided by 1,000, giving you 149.4. Yeah, that is it, which is approximately 150 million kilometers. Yeah, this is the approximate distance of the Sun from the Earth. Here, how to go about this? Here you have to be reminded that distance is equal to speed times time. Okay. Then we know the distance already. The distance is 44951, and then 0, I mean, there are 5, then times 1000, because we need to convert it to meters, and these are kilometers. So this will give us 44951, then 0, then additional 3 zeros, meters. Okay. Then what else do we know? We know that the speed. Remember, we are considering light, and the speed of light is constant. It is 3 times 10 power 8 meters per second. Okay. Yeah, here we put, yes. So that's what we have. What is next? Next is to substitute. You substitute for distance, which is 44951, then 0, then 0, like that. And you substitute also for speed, which is 3 times 10 power 8, then times time. It is the time which we are looking for here. Yeah, that's what we have. So we have this time in seconds, but they wanted us to convert it to light hours. This is light second. So what do we do? You divide by 3600. So time in hours is going to be 14983.67 divided by 3600. Yes, 1 hour has 3600 seconds. So what you get out of this is going to be the time in hours, which is wanted. Yeah, that is that. So this is what we have in light hours, 4.16 light hours. So in other words, light will take 4.16 hours to move from Earth to Neptune. Neptune, we have to remember that it's the farthest planet, the most distant. So that is it. And with that, I would like to thank you for your time. The channel is Natural Sciences Grade 8 and 9. That's the name of the channel. We urge you to subscribe, to comment, to like, to share. Yes, we believe we are the best. Stick with us. You won't regret. See you next time. Bye-bye.